Welcome to my talk. The topic is automated upgrades of PostgreSQL clusters in cloud. Basically, we will talk PG logical, PG bouncer, and logical upgrade using automation tool of Ansible. So that's the generic idea. So I would like to introduce myself a bit. I work as site reliability engineer in 2ndQuadrant, which is a Postgres company, maybe some of you have heard before. I am a board member, recently elected to board of directors in PostgreSQL. I just graduated from my master's in technique. I'm really happy about that. And I'm from Turkey. That's it, and you can find me by my Twitter handle and follow me on GitHub or contact me on Skype. So what are the topics that we will talk today? First, we will mention how many methods that generally database upgrades uses. I do some research about the other databases as well, not only PostgreSQL. I feel that there are really many commonalities between the databases. And then we will talk why logical replication is means of upgrade, and how I implemented the tool. It's a platform because it's also provisioned instances on Amazon. And what are the case studies I did, and what are the results that I found, and benchmarking the results, and I will interpret them. And we will talk about if it's applicable to other systems, and what are the limitations which comes from the replication or the tool itself. So, first thing, when we talk about upgrades, it is still the case that when you need to do major version upgrade, I exclude minor version upgrades, we need downtime, which basically means that you can't do your service. Your service is not available. So you kind of have the cost of financial aspects from that. You might lose some revenue, and you can lose your customers by reputational loss because they don't know why you are closed or not. And if you can't fit in this upgrade maintenance window, you may have some problems related with that. You may not meet your SLAs, or you need to think about serving in lower capacity than normal. So when we say database, I mean database upgrade problem is a problem that affects almost everyone because I don't think nobody is using databases, or at least you are using something that uses databases. So upgrade problem is actually affects many people than thought. And also data is considered one of the most valuable assets for many companies. So it is very important in every scale, startups, medium sizes, and enterprises itself. So if you find a solution that solves the upgrade problem and minimizes the downtime, it will affect everyone, which will make everyone's lives easier. And also there is one more thing that I want to focus here, that when we say database, I actually don't mean only one instance, because usually nowadays none of us using one instance, right? We use more than one instance, with replication between or we do partitioning or many use cases, but we almost not likely to use one instance. So if we will solve this problem, we need to think about in cluster size. So here you may say that it is risky. It requires downtime with accurate methods, and it takes so much time to plan. And also I was doing some research on it, and one study says that in 2015 there were 200 companies questioned, and they said more than 60% of them just avoid security patches, which means that if you're thinking databases are very critical, you are vulnerable to attacks by your databases, and then you are missing security patches by just deciding not to do it. But you should know that what kind of trade-offs you are giving. You are missing the new features, you are missing the performance updates possibly, and then you have to deal with the poor performance and hard to maintain code, which is buggy possibly, and at some point you might not have official support anymore. So it's it costs a lot. So if you fix this problem, I think we all will benefit from it. Okay, we decided to do upgrade, and why to automate that? And I know most of the people think that configuration management is something that you need to think about it extra. So when you think about something as an extra, you just don't want to deal with it. But in case of Ansible, this is the logo of Ansible, I never thought that this is an extra thing, because if you have a SSH connection within your servers, you don't need to do install any agents, It doesn't require much thing to learn. It is like written with configuration, like configuration management language. There is like YAML, so it's very simple and close to like English. And for the templating, you have Jinja 2, and it is like available lots of filters. You can do many stuff, and like it's very easy to do. So you can try if you don't believe me. And for automation, there is one thing that I kind of like, I come from like database administrator background, and there are some things that you need to do like lots of time, and like in case of upgrade, every like major version you need to do, and you need to keep up with the up to date. So if something needs to be repeating, then you need to once automate it and use it forever. And it is of course efficient compared to manual tasks, so you will reduce the cost and you will eliminate the risks related with humans and like human-based errors. And the results are reproducible, and you can put this to like a version control system, so you can be sure that you are not the only person who can do this process. As a DBA, yeah, you do this, you know that how to do, but what if you are not here, or like there are some juniors to you that you need to teach these things? So if there is an automated script, it will be beneficial for everyone. And in this example, I took from like Ansible's website. It was like showing how they achieved better results with like updating NASA and like fetching updates from multi-days to like some minutes. So it's really useful. And as I can say, for my opinion, I'm not from like very heavy programming background, but as a system administrator and like database administrator, it's very easy to use Ansible because it doesn't require much to learn at least. This is not the first time that I am using this Ansible for like a solution for PostgreSQL. In 2015 for PTConf conference, I prepared a talk with how to do physical replication with using Ansible and using PostgreSQL modules altogether. So I thought that it's very easy to do for like physical replication, and then since we have like logical replication coming in Postgres 10, I thought, okay, I should like discover how to upgrade by using logical replication. So I kind of get this idea before, but then I use this here. And PostgreSQL has a term for, Ansible has a term called modules. Has anyone of you used Ansible before? Wow, it is the most like answer that I get from any of the like PostgreSQL. Okay, then like you know modules, and they are like simple programs. For example, in Postgres they have like 6. Postgres create DB or Postgres extension, so you can just create databases and extensions and users, and you can delete them and so on. So it's really convenient to use if you have like simple tasks to do, and you can call them from your tasks. And Ansible has a great community, I would say, and they share all the roles that they write. Roles means that like they write playbooks, which is like application code basically. And for huge playbooks, you need to kind of organize them with roles. For example, in my code that I have PG bouncer role, PG vertical role, and Postgres roles, because they are the like main things and with their main functionalities. So once I need something with Postgres, I don't need to write every time, and I don't need to repeat all the templates and everything. So I just call Postgres role basically. So I was just checking Ansible Galaxy and how many times I like in April, I guess I did this 50 times an upgrade, like roles related with upgrades, like 252 times PostgreSQL roles. So it's very good if you want to try and learn. So, in terms of upgrades, when we talk about them, as I mentioned before, they are all like having some similarities between all the databases. First one is like, first approach will be that databases keep their storage format same, or like at least compatible at least like across versions. So it is like a bit hard to guarantee in long term, because you need to like for like new features might require some changes in how data is stored, or for some optimizations you need to change data structures. So it might be different to like hard to keep. But this is the like first approach that is done for database updates. Second is like basically having a logical copy and then like restoring into a new server. This is the very most traditional like approach, and you see in almost every database system. But it requires like offline. You can't like serve in the time. So if you have like very large database, it might take days or even like many days. It depends on how your database is big. So the third option is like converting data from old format to new. It can be online, but then you don't know like how performance issue will be related to, like, because the access patterns are different, and like it might be like different for all the systems. You can do it offline, but then there is a second method. You don't actually gain much from this. But it is often shorter if there is not much change between, and if you are using the existing database. You only change the data directories, but you use still the same of user data. So it might be shorter. But today, we will focus on logical dump. And it's not like the second method, but it's like logical replication. Why it is different? Because it doesn't need to be offline anymore. You can still serve while you do this upgrade. So how it does that, it captures changes while the upgrade is happening, and then replicates after, like the changes after the replication is done, after the restore is done. So this is the only method that we can achieve minimum downtime. The others are all requiring downtime. So this is the fourth and like the most favorite method if you are aiming to have like minimum downtime. Here I would like to match like some of them to give a better idea, just not numbers. For example, when I say first one, what we can recall in Postgres is minor version upgrades, because like minor version upgrades doesn't have any features, so they keep the data format is safe. For the second one, I mean, we all know, like pgdump and pgrestore, this is the most specific one. So it's like convenient at times, it depends on your need. For the third one, we have a pgupgrade, so we can match it in that way. It changes the data format. And the fourth one, it will be any kind of logical replication can fit in this. So when I say logical replication, we can think of like trigger-based replication solutions as well, in Sloney or like long step. But they have their own caveats. So in the talk, I won't be doing some solution with trigger-based replications because like basically it has more effect on the system than logical replication and in pglogical. So if you were in Magnus's talk, he was explaining why trigger-based solutions are kind of like not very useful today, if they were very useful even before we have a physical replication, because they double the writes, which is that they say the changes into the tables, and then it doubles the writes, it doubles the logs, and it has like different logics to keep it. So here we have like more advantage because we have logical decoding in PostgreSQL now after 9.4. So it's better to focus on this and learn before it gets completely in PostgreSQL. So as I already started mentioning, logical replication, I can step it. And as you can see, there's two main categories. One is like offline in pgdump and pgrestore, and the other one is in pgupgrade. For online conversion, the tool that I write for pglupgrade, so it is the tool's name. The pglogical is the logical extension that I use. We can put these like trigger-based replication solutions here, but we already mentioned that. So this is like the main picture so that you can understand what it is actually. But there is one thing to say when we talk about like offline conversion. They are traditionally can only update one primary server, while the replica servers have to rebuild afterwards. We also don't need to deal with this in logical replication, so we can still like do replication while the system is up and running and it's like serving the queries. So this effort will be handled. Also, in the like offline conversion methods, you don't have the chance to test the like systems all together in parallel because you need to shut down. And for the online conversion, for example, in pglogical like example, then you can still like have the both versions installed because they're like replicating, and then you can still do your test with old version and new version together. So it's another advantage, we could say. But like all of the versions like this, all of them has like different uses. For example, for pgdump, we can use from very old versions. If you are using very old version, like let's say Postgres 7 even, you have the support. So until you come to the 9.4, you still have these options to try. And for pgupgrade, it is from 8.4 or later. So we need to have different cases. But for pglogical and pglupgrade, why we are able to use this as an upgrade, because we actually don't need same versions. I mean, we can do like replication between across different versions. That's why we have the use case of upgrade. So that's very important to understand. Basically, that's all for this presentation. Next slide. So let's talk about generally a bit how the solution, what the solution compromises of which elements basically. So as the name says, pglupgrade, it's like a PostgreSQL logical upgrade tool. So it aims minimum downtime, utilizes pglogical and pgbouncer. I think you also application proxy. When we finish the upgrade, we need to switch from the old application version to the new one, to like your application need to connect to the new database basically. So that's why we need PG bouncer. So it's something that is not that we can solve in Postgres itself because it's not our like Postgres function, but you can do it with any other thing, and you can just remove this role from the tool, and you can do your logic in your application or some other way. So because it is not the must thing, but we use it for like transient change. And it runs, I run the test and like provision the instances on AWS. I have a like playbook for that as well. So this is actually the generality. So I will just show how like a playbook like works a bit. I will mention. So I have one big playbook. It has 8 plays. It's not very big, but it's just calls like 8. It has 8 plays, and each of the plays using one inventory file. I mean, not all inventory, but which host they would like to run, because I have different groups of hosts. As you can see, there is one old primary group, which will be like the upgraded one, and new primary old standbys. There are existing standbys, and there are new standbys. This inventory file was for my first case scenario. It will be different for each of the cases. But as you can see, you can just, there's like inheritance. So you can use old standbys as new standbys in the upgrade. So I have two-step configuration of standbys. It allows me to reuse the standbys. So in that regard, it's like one of the good things about this. And of course, I have like pglupgrade host, which is like obviously it's needed. So once you have inventory file, I provision the instances and I took the IP addresses here. But if you've already some other instances, you can give the ID as well, so IPs as well, so it's fine. And I will show the configuration YAML as well. There I am saving where I will set ID. So that's it. If you have inventory file ready, and we already write the like playbook, so we just run Ansible playbook command and call the inventory file, and then you can just orchestrate all the update operation with this. Unfortunately, I'm not sharing all the code, but I will describe how the logic works so that you can apply as well. So here, as you can see, like very like basic things. Of course, when you want to like upgrade from one version to another, you need to have these variables and like any other variables that you require for like Postgres setups and like some internal logical requirements and connection strings. And for, even as you can see, for connection strings, they are like configurable so that you can change databases, users, or your like you can refer to all primary and primary differently. So this is really like flexible. I really like Ansible in this thing. But the main thing, like specific to this code, is initial standbys. This is like designed to key for designing high availability properties for the cluster, while the upgrade operation is still running. So you don't need to deal with any other thing, it's already set. So when like for example, if you have like 4 servers and you set initial standbys 1, which means that you will have 1 primary and 1 initial standby in the new version, and then the other 2 will be rebuilt afterwards. Afterwards is like new ones. So you have like, I will show in the case study. So you have 1 new, one old version. You can do tests and you can do failover. And then after this operation is done, like if you remember in the inventory file, we refer to old standbys in the new standby groups, so that you can use the old idle like version to be rebuilt as like new standbys. So this is the 2-step configuration that I mentioned for standbys. I think this is the important point. It was a different point here. So this schematic workflow diagram shows that how the code itself in this one playbook works. First, it has 8 plays, I said. First play, just this like divides these groups basically, sets up the old primary, new primary, like old standbys, final new standbys, and so on. So basically it does builds these internal groups and servers based on the configuration and the inventory together. So this was like preparation thing. And the second thing is it sets up new clusters with the new primary and like new standby if you define initial standbys. So this is like the new version, and then it goes through this like yellow part, and it modifies the old primary to support logical replication, because here we already have physical replication, but we will use logical replication to upgrade, so we need to modify the old primary. How we do that, which means you need to like install pglogical extension and start a publisher, set the publisher, and add your old tables and sequences to this publisher. So then it is ready and is modified as like supporting for logical replication. That is the yellow part. And then after this is finishing, you need to replicate to the new primary. How it starts? When you went to the new primary and starts like subscriber there, it triggers as like starting the logical replication. So once you start the subscriber on the new master, which acts as like a trigger. So this play goes until it replicates the initial data. So once it like replicates the initial data, and it starts to catch up after like what changed when you start the replication, because you start at a point copy initially, and then there is like still some changes. Then it comes to this purple box, which is PG bouncer role, and play actually uses PG bouncer role. You need to watch. I mean, if the task is watching, that if the replication leg converges to 0, not 0 because you might not never get it, because if you still accept the writes, and you will never catch the leg, basically. It's going to be never 0. So at some point you need to stop it. I put a limit for like 16 megabytes because it is like a ball size basically. So once you get this divergence, you pause the PG bouncer so that you don't exert any connections. But if the connections if the query is already started, they will finish, but you won't exert more. Of course, this will create lag because basically this is the downtime. You don't serve, but when you stop the pause the PG bouncer, it will get to 0. All the other existing ones will finish, and then the replication will be 0. Then you will just point to the new primary, and then reload it, and then you resume the PG bouncer, and then all the waiting connections will go to the new primary. So that is the switch basically. So after you switch, basically you need to remove the connection for basically you don't need anymore the logical replication. So you need to remove publisher and stop the old instances because you don't want the old ones to connect anymore. And then if you have as you say, we had initial standbys one, but we still have the old two, right? Now they are not in the use. So then the last play just to base backup basically and rebuild the standbys. You can even use the old primary, as it doesn't matter if you have the connection already defined in inventory. That's it. So basically you are done. This is how it works. And I would like to share, we mentioned this case studies a bit vaguely, but now we will see in schematics. So for evaluating these efforts, because you need to somehow apply to in these real life scenarios, I tested in two cases for different purposes, because it's never one purpose in real life, as you know. I use PG bench, and that's it. For this one, now you can understand actually what is the thing. As you see, there is one PG bouncer host, one primary, and 3 standbys. So it's very normal high availability case. And then since it was initial standby 1, this picture, so you have one primary 9.6 and one standby 9.6, because first before upgrade you need to be sure that this will be the case. And then you start to replicate from 9.5 to 9.6 until this diverge, until this leg thing finishes. So once it's done, when you stop sending requests queries to the old version, you use the new version. So this is your your new cluster now. And then since there is 2 more, and we already pointed them that they will be the final standbys, you rebuild them. So you actually have the same cluster back without any issues, and the upgrade completely achieved. The good thing is here that if there's something going wrong, you can just fail back to the old version before, of course, cutting them. And the upgrade will not be successfully completed, but at least you are not doomed altogether. So it's better, I would say. And it is the second case. In this case, this scenario simulates that there is an application they do really high amount of reads, so you can't do like as the first method, you can't divide in half and like lower the capacity because mainly it won't work. So you need like this kind, like how many amount of standbys you have in common one primary, you need to have another copy of it. So like if here I use like 10 standbys and one primary, then you need to have one more primary for new version and 10 standbys more. It's very easy to do that. Like instead of like pointing to the like existing servers, you need to give the IP addresses and hosting manager that you created by like provisioning. So you will start with like empty cluster basically, and then you'll start with the replication, and then from this moment it's the same. It waits until the replication that gets to a certain point, and then when it's done, you just go into PG browser and using the connection to the new one, and you have the same cluster you started. But here, this like cluster in the left one, old one is idle. That's the beauty of like why we are using actually the cloud systems. It's very easy to terminate them. You don't need to pay. You just pay as you go, and the billing is very flexible. In old times, it will be very hard what we will do with lots of machines, and they might be very big and expensive, and it's like not that easy to buy and like continue. At least it was not. So it's very easy for testing reasons as well. Okay. So this was they were the case studies. And what was the test environment looking like? All tests were running on Amazon EC2 instances and on, of course, 64-bit systems. And they had two virtual CPUs and 4 gigabytes of RAM and 110 gigabytes of EBA storage. And I used pgbench for like scale factor 2000. It made like 27 gigabytes of database because it was enough for the test, I will say. And also there was one thing that I did before the upgrade. I ran 2 hours for generating transactions to pgbench. And during the online upgrade, pgbench was still working because it was my application as well to want to test. But of course, for the other methods that I also run this clusters for 2 case studies, for pgdown, render store, and pgupgrade, it wasn't possible to run pgbench at that time because they are offline. And these were the software versions from 9.5 to 9.6, and pglogical version 2, pgbouncer 1.7, and on Ubuntu machines. So these are the results. First, I would like to say the victory part. And as you see, Pglupgrade achieved the minimum downtime, which is at the very right corner, which is from like comparing to the other ones from minutes, like almost like half an hour, to like 3 seconds and 5 seconds. This first one is for the first case, the one that we really used the standby, and this one was like bigger cluster with 10 standbys. So as you see, it doesn't matter. Actually, it's getting even better when you have more and new servers, empty clusters, I mean. So I achieved that. But let's talk about a bit details. I mean, but just not only the numbers, but what was the background story behind that. First, like metrics, what kind of metrics I kind of check. Of course, the aim was for like proving the primary runtime will be removed. What's primary runtime? Which means that you don't serve it, then your application is not serving, the database is not serving. So that was the time that I calculated. And there is also partial cluster high-availability. I said that for if you start like, if you have one master and one standby, I said it's like, okay. So it's set to start. I mean, if something goes wrong, you still have standby. That was the limit for that. And for full cluster capacity, it's like how your like cluster normally works. So it's like full time, like everything is working, full capacity. Then it turns to that level. And how much the whole upgrade takes. I also calculated this rebuilding of the standbys and stuff. And how much extra space is used. There are like some stuff that I will mention why, for example, Pglupgrade 27 gigabytes because I didn't want to use hard link because it was like kind of not safe. So if I lose, I can turn back. So I tried to make all the options as safe as possible. And for example, I didn't rebuild all of the standbys altogether because of the load issue and stuff like that. So there were like some concerns. So I tried to be fair in every option. So as you can see, for example, for the first case, let's say for the pgdump and pgrestore, it basically took 16 minutes or something, and then 12 for restoring. But since we had initial standby 1, once we have primary, we have like also standby. So primary downtime and partial cluster achieved in the same time. But then there were two more that needs to be rebuilt. That is full cluster capacity and then top upgrade as well, because everything is like restored. So that was for the case for pgdump and restore. It took 1 hour altogether. And actually this space was very like small. Dump was like not taking too much like space. For the PG upgrade, you need the copy of the data directory. You need like it was 16 minutes, and then for partial, you need to have one like for one standby to have like also updated. So since it was existing, you don't need to do from zero. So it was just arcing the difference, and then that's why since once you do that, they're all existing. It didn't like change much time, so it was all same. And for our case, the small amount of time is, if you remember, when we like stopped PG bouncer, we couldn't like respond to the queries. That 3 seconds is coming from there until we do the switch. So that's why the downtime is very minimal. But then you all need to like initially copy the stuff and make all the replication changes to send basically. That's why it's all take like, because there is like 2 more to go altogether. And 10 GB is coming from that while you are doing upgrade, there are still changes happening, because I was saying that I run PG bench. For the second case, let's talk, is again like the primary downtime is very like minimum comparing to the other methods. Since like here, we say initial standby is 10. So if you have like 1 primary and 10 standby, you need to initially have all of the 10. Again, when you do pgdump and restore, once restore is completed, all of them are standbys, and then all of them are restored at the same time. So it's like length of upgrade, full cluster capacity, partial cluster which is achieved at the same time. And so like for the PG upgrade, is again like one is here is like it's not like the case optimistic as like the first case, because there it was we were using the existing servers, but here as you remember, we created empty cluster for 9.6. So you need to rebuild it from like scratch. That's why I did like 2 by 2, I guess, for the standby. So it took like like getting more and more until like 3 hours or 20 minutes or something. But it's like the same size again. And for PGL upgrade, this is like very like good, because you need to like all of them are already like replicated because they are new, and altogether you need to still like send the changes. This was like our application basically, and that's it. This is a very important page for the presentation, I must say. If you will check through afterwards after I publish. And it was like PGL upgrade method was the only one keep cluster running while the upgrades is happening. So this is the take from that presentation, that page as well. So let's like interpret the results, what was the case. So I was just checking PG stat replication, PG stat activity, and checking the data size, like the data directory size, and how PG bench progress works, like for checking latency and TPS. And here you see once you like start initial data copy, it takes like really like it's getting growing and growing and growing. Once we come to the indexes, it's just like not that high steep growth, and then it gets up to like changes, and then something happening, and database size is almost like the same. Like it was 2730 from at the beginning. It's a bit more, but it happens. So this is logical replication initialization part. And this one, I would like to say, for example, once the initial upgrade of the primary server is done, either in like pgdump or restore or in pg upgrade, the standbys are added. So cloning of standbys usually happens like when the primary is already being used. So you need to consider that it's not feasible to clone too many like standbys, because you need to either serialize it or like do it like a couple of servers at a time, because there's, as you see, there is like impact on performance. Once you started to clone, there is almost like 25% drop. This is not for the logical case. This is, I'm talking about for pgdump, restore, or pg upgrade. Basically, when you need to like rebuild the standbys. So this is like good to see the impact, because usually shouldn't think that when you do logical replication, there won't be any like impact on the system that you are running. There will be impact, but since there will be impact in any case when you do the standby, it just will make more sense. So let's see how performance of server affected by the logical upgrade process. So as you see, once we start to do initial copy, like until the index part, it is almost like similar part with the previous page. There is like effect. So you need to be, I think if you still plan to do upgrade, you need to think a bit like low files. You need to be like thinking that there will be performance drop for like 5% or something. So you need to have like some spare like resources. But until when you get the index part, then it's like index and catch-up phases have minimal effect on the system. So you can like easily test your system until you are sure that there is no problem on like new version, in our case 9.56. So it is like until that point. After that point, it's okay. But one more like label there is like switching. So this is like when we do the switch once the like replication is almost 0, and like we waited. So here like 3 seconds or something that you couldn't serve. So latency is going up. Basically, normally it will be downtime. But here, like you see the latency because the application didn't get error. Because of why VPG bounce rate is also PostgreSQL protocol error. So it's more transient than using some other proxy. So it's like showing this is kind of how we achieved. It's like proofs. It's just like some seconds, basically. 3 seconds, because it was from the first case. So feature for this tool, I think, is good enough. And because I was checking the PGCon developer meeting, there was a discussion for like automated solutions for upgrades, and near zero downtime upgrades is important. As I realized, it's not our like only PostgreSQL problem, because almost all databases have this problem. Yeah, I mean, they say that we do like near zero downtime upgrades, but when I check their documentation, like there is like tooling needed everywhere. And if you compare it like other licensing fees and registration fees, and it also changes by how many instances you have. In Postgres, we don't need this problem. We don't have this problem, so we can just easily try everything we have in many instances. Something like that. I don't know what. Yeah, it's just some of the stuff. It was not the end one. Yeah, there's some. Oh, yeah. Okay, then I don't move anymore. So the future is bright, there's a need, and it's an actual need, I guess. Maybe that I'm like not looking as very objective now, because yeah, there's a tool now, I'm happy that it's like doable, and everyone can write their own or check. And the tool we'll be using for our customers, the company that I work for. And another good thing is that why pglogical is also important, why the tools like using pglogical is important, because PostgreSQL 10 will have built-in logical replication, and it is the same people basically writing it, and it will be having the same feature sets and like maybe different applications. Like for example, in pglogical you are writing with like functions, but then in like PostgreSQL it will be different, like create, subscription or stuff like that. So like the syntax might be different, but the idea is the same. So pglogical, like eventually, will be all in PostgreSQL, hopefully, not in all like already in PostgreSQL 10, but it will be all like maybe PostgreSQL 11. So eventually, we will get all the features. So then it will be a bit easier. Okay. So what is the applicability? I mean, if this tool is like obsolete or it will work only for like one thing? No, it's not. As you, if you're already using Ansible, you know that it doesn't matter where you run this code. It can be on it will be working same in traditional data centers or on both can be bare metals or virtual servers. It doesn't matter, or in cloud. I use cloud because it was more convenient for me, but you can use for any other system. There's also, of course, there's one exception for a implementation side. PGL upgrade scripts will work on like many operating systems, but you need to change some of the parts because some of them are related with Linux commands. You need to apply them, twist it a bit. And also, since as we see, there were 4 main approaches for all database upgrades. So when you have logical replication, I checked MySQL has Beanstalk replication, and Oracle has Golden Gate, I guess, if I'm not wrong. And these are all logical replication in like the theory, so they can be used this tool as well. So if you have like logical replication, basically you string the logical changes somehow, so then you can work with this as well. Also, we were mentioning that PG bouncer is one of the key factors in the tool, but it was for making things more convenient. But if you don't use PG bouncer, you just remove the basically disable the parts and then use with some other solution. So it can work without that. But it has own advantages, as we said. So what are the limitations? Of course, not every solution fixes every problem. For example, as we see, do you remember this interpreting the results graphics? If you are not having no resource, it can be overload the system. So you need to be really realizing that you need to have some spare resources on primary server. So it will be limiting the Pglupgrade, will limiting the server usability. So you don't want to overload completely, because if you are still serving the things, that was it's easy when you do Pglupgrade or Pgdump restore, you're just off. You know that there's not a load, but you need to be sure, and you need to consider still lower times of your system, and you need to also consider that if your class is with too many writes, then there's a time that I want to wait the logical replication to catch up. If there's too many writes are coming, and you may never get to this small different replication leg. So you need to be sure if your system is getting too many writes, maybe it might not be the case, and it's can take longer to replication to catch up, or it will never catch up maybe. Also, there is one restriction comes with pglogical. It only replicates tables with primary keys or inserted only tables. So this is a valid restriction. But in Postgres 10, it will be fixed. This problem won't be there, as I heard. And for the last topic, in neither pglogical or logical replication, they don't do transparent DDL replication. But for my opinion, you shouldn't do DDL before your upgrade, so you can be sure of it. But better to know if you expect that. So what is the conclusion? It actually can be achievable, upgrade with minimal downtime. In PostgreSQL, I tested. You can test for other solutions as well. And an application, we can change our perspective how we understand upgrades, because when we heard major version upgrades, we were thinking downtime at the very beginning. But now we don't have to be thinking like that. And we are doing in a better way. Of course, it can be done with trigger-based versions as well. We talk the solutions. But this is more convenient and natural for PostgreSQL now, and has many advantages. It doesn't create that much effect on the system. It's smarter, maybe. And case studies prove that it is achievable. You can also try in your systems with a similar logic. And thank you for listening to me, and I really enjoyed the conference, and I'm happy to be here. Hopefully, we would like to see you in Postgres Europe events as well, and I'm really happy to be here. Thank you. I don't know how much time I use because I don't have the timing here. Do we have time, or did I finish already? 5 minutes. Oh, good. Good time.
Is your playbook published?
I think I need to talk with my company before, because I wrote this for my thesis. For academic reasons, it's all okay. But then I kind of expanded it for some uses as well. Then I don't know. But I think if you are interested, I can explain. So I don't need to publish, but you can all understand. It's so easy. I just do pglogical. If you know how pglogical works, you're just creating subscription publisher, and then basically you just do pglogical things, and then just orchestrate things. You can do it with any other configuration management tool as well. It's just everything is there. I didn't do anything, so it's just making things together.
For how long was running before actually starting?
2 hours.
2 hours. Have you heard about IO bursts and CPU bursts on AWS? So have you used IO1 volume or GP2?
I don't remember.
EBS volume, what type?
It was IO1, I guess.
If it was IO1, and so maybe it's not a. issue,
But
but I would really like to know how many IOPS have you provisioned.
I can actually check because I have the result.
Because if it was running with GP2, obviously it exhausted
because I didn't have
it.
it.
Was able to perform only with baseline performance. And actually, if you are not able to burst up to 3,000 IOPS, you are really slowing everything down.
Yeah. I didn't have the issue. It's possible,
Like probably 2 hours is not enough to exhaust CPU resources.
Yeah.
Like for 42 medium, it has to be like much bigger. And I'm not sure whether PG1 PGBench is able to provide so high CPU.
I was like making it to a bit like closer to normal life, but it was not the case. Of course, in 2 hours you can't get like real loads, like system load. But I thought it's at least still better to do something before than just starting freshly. It is closer to do.
Anyway, I would really like to know what kind of storage was used.
Okay, I will. I mean,
if it was GP2, obviously these results are unfair.
I think it was not GP2. That's why I think. I need to check again because it was in April and I don't know. I just know that it was 110 gigabytes of EBS, but I really don't know the type now. I don't remember. Okay, but I can check. I will have my files.
So, what are your reservations against doing Pglupgrade with the hard links like -k? You said it's dangerous, but what are you?
No, for me, I was like scared too because there is no way back to turn if you don't, if you do without like this. If you do with hard link, once it's done, like upgrade, you can turn back to old system. So I wanted to have a second copy if things turn like nothing goes well.
But before you actually started a new cluster, you can just wipe out the new one and start the old one and block it. So as long as you started the new one, you won't be able to turn back. But before that time, you can actually turn back. And
yeah, true. But I thought it's like I don't know. It feels safer. Because I kind of afraid of Pglupgrade personally. I don't know. Sometimes I miss things.
Because the hard links will reduce this time from our.
Yes, definitely. Yes, it is like in that case. That's why I mentioned because it's not. This is the case that I use it that way. But yeah, it will be obviously shorter and less. I guess it's done.
If there is no questions, thank you, Gulcin.
Thank you, Alexis.